method. If you know a more efficient method, that's fine, use that, but I'm going to use the flowchart method to demonstrate how to solve these. So first of all, we've got 4x equals 12. Well, we start with the x, and the 4 bit means that the x is being times by 4. The times sign is frequently left out in equations. The add and subtract and divide signs aren't, but the times sign is. So 4x means 4 times x. So we get our x, we times it by 4. And if you do that, you'll end up with the number 12. How do I know that? Well, I've just rewritten this into a flowchart. And why have I done it? Well, to work out my answer, I could just go backwards through the flowchart. So 12, and the opposite of the inverse of timesing by 4 is dividing by 4. 12 divided by 4 is 3. So the answer is x equals 3. Question number 2. Solve y minus 7 equals 11. Same thing. Start with y, take away 7 from it, and you'll end up with 11. All I've done is I've taken the equation here and I've written it in the flowchart, so I can go backwards. So the inverse of taking 7 is adding 7, and 11 add 7 is 18, so y equals 18. Now a slightly trickier one. Why is it trickier? Well, there's two things going on here, and we'll see this when we write the flowchart. Start with the p. The first thing that happens to the p is the 5. It gets times by the 5, multiplied. And after that, 16 gets subtracted. And if you do that to p, then you will end up with the number 4. And the reason I've written it like this is because to find out what p must be, I just go backwards through it. So I add 16, that gets me to 20, and then I divide by 5, which gets me to 4. So p equals 4. You should know that there's only one possible number that will work in this. P can't be anything other than 4, in the same way that y could only be 18 in this one, and in the first one, x could only be 3. So you are looking for a unique solution. There isn't another one. There are some equations that have more than one solution, but they won't be in the foundation paper. Okay, question 4. Now, this is a bit trickier. What I do when I look at one of these, I look at the q's. Now, some people will say there's one q over here and one q here. That's not true. There are 2 q's here on this side of the equal sign, and there are 5 q's here. And I pick the side with the least q's, that's this side, and I subtract that many q's. And I have to do it off both sides in order to keep it equal. So, subtract the 2q, by 2q, I'm left with a minus 4. And over here, 5q take 2q, well that's 3q, add 5. And that's the thing I was after, because believe it or not, that's the same sort of equation that we solved in question 3. And I'm going to do it in the flowchart. Now, it's the other way round. Up here we had the 5p and the 16 and it equaled the 4. Here, the 3q and the 5 are on this side and it equals the minus 4. But that doesn't matter because all the equal sign is saying that they're the same. So I start with the q, and it gets times by 3. And then 5 is added onto it. And if you do that, you will get the answer of negative 4. And so to solve that, to work out what q is, we just do it backwards. So we take 5. Now you've got to be careful here. And at this point you may well resort to a number line. So minus 4, there's 0. Now minus 4, take 5. So if we go up, that would be adding, wouldn't it? Because on the number line, you know, it goes 1, 2. So this is the adding direction. So we're going to go down in the minusing direction. So minus 4 minus 5 will give us minus 9. Now the reverse of timesing by 3 is dividing by 3. And 9 divided by 3 is 3. But it's not 9, it's minus 9. So the answer is minus 3. Question 5. Well, doesn't get much more tricky than this. The first thing we've got to do here is multiplying out our brackets. So this will, remember the bit we did earlier, and there was I think the second puzzles were multiplying out brackets. So I'm going to deal with this one first. So I'll do a little grid over here. And there's a 3 there, and then 2x minus 1. And so in my grid I'm going to have 3 times 2x, which is 6x. It's not 5x, I'm multiplying, and 3 ones are 3, so it's minus. So over here I put 6x minus 3, and I've done this bit. And now I'm going to do the other bracket. So I've got minus 2, and on top 5 plus 3x. So that gives me minus 10 in there, and minus 6x here. Interesting. Fair enough. Okay, so I have the minus 10 and the minus 6x. And now I simplify it. So I'm going to start with the 6x's because 6x and a minus 6x leave me with no x's at all, which means that y is equal to minus 3 minus 10, which is minus 13. And that's my answer. Wasn't that bad, was it? Now, question number 6. This is something which is very, very likely to turn up on either the higher or the foundation because it's a sort of grade C topic, and it's trial and improvement. Normally it says that. Trial and improvement. Which is basically another way of saying guess. So we start with a little table. We have our guess here. Then we have our equation in the middle. And then at the end we have a comment. Now, they tell us that the answer to this is in between 4 and 5. Okay, so here's the equation, and the answer is between 4 and 5. So I'm going to start with the one in the middle, 4.5. And the very first time I would write this out fully, just exactly like I'm doing it now. I would do this in an exam. Let's just stop and make sure you understand where that came from. I've written 4.5 cubed because x is cubed and x is 4.5, so it's 4.5 cubed. I'll put the minus in and the 5. And remember what we said earlier, 5x means 5 times x, and of course x is 4.5. And I type that into my calculator exactly like you see it. So 4.5 cubed, there is a cubed button on the school calculators, minus 5 times 4.5. And I get the grand answer of 68. 68.625. And of course I wanted an answer of 60. There's the answer. This is what I'm looking for just here. So my answer is too small, too big even. So 4.5 is too big, so I'm going to go to 4.4 now. And at this stage I'm going to edit it on my calculator. I'm going to use the edit button because it's a lot quicker, and I'm just turning all my 4.5s into 4.4s. And that gives me the answer of 63.184. And that's also too big. And notice I'm just writing the answer in. That's important. That is my insurance, because if I mess up later, but I have done this right, then I can score some points just by the numbers lying around and showing the examiners that I knew what I was doing when I put the numbers in. So this one gives me 58.007, and this one is too small. So I've got one that's too big, that's this one, and one that's too small, that's this one. So I've got 2 out of the 4 marks. Now to get the third mark I need to do one in between, so 4.35. And again I just edit my calculator and turn it into the 4.3s into 4.35s, hit equals, and that one gives me 60.563. And that's too big, only just. Don't be tempted to try and get any more accurate than this. The question has only, and this is almost always the case in the exam questions, it's asked me for 1 decimal place, which means that the answer is going to be either this number or this number. It's not going to be this one because this is a 2 decimal place number. So I just have to decide, is it 4.4 and 4 or 4.3? And this is how I decide for my last mark. Here's a little number line. So there's 4.4 and there's 4.3. Let's do it the other way around. For some reason I've got it in my head, it's 4.5. 4.3, 4.4. Now 4.3 was too small. and 4.3 was too big. And the middle, 4.35, well, that was too big. And what that tells me is the answer is in between here. Because if you go past here, it's definitely too big, and if you go past here, it's too small. So the nearest of the two numbers that I'm after is, as I hope you can see really clearly, is this one, because the 4.4 is way away if the answer's down in the bottom half. So for the fourth mark, I have to select the right answer, which is that one. Now we're going to finish off with the challenge question, which is tempting to disappear here. Okay, so let's see. So we've got an isosceles triangle, and AB equals AC. We can see that they're telling us that. This is what these lines mean. It's the same length of sides. And first of all, it says explain why 3x minus 10 equals x plus 30. And the reason is very straightforward. There's only one mark for this. It's because the two angles, the two bottom angles, of an isosceles triangle are equal. Okay, and because they're equal, this is one of them and this is the other, so they equal each other. And now it says solve it. Okay, well this is like the one we did earlier. So there's two things on each side of the equal sign, and remember what I said, we look at the x's first. So if you haven't already had a go at this, pause and have a go now. Now, this side has got the fewest number of x's. There's 3 here and 1 here, so I'm going to take away an x off each side, and that leaves me with 2 x's on this side, and the minus 10. And the x is taken away, so it leaves me with the positive 30. And plus 30 and positive 30 are the same thing. I know it's a bit confusing, but it's true. And now I'm going to use the flowchart, so I start with the x, gets times by 2, and then 10 gets subtracted, and if you do that you'll end up with 30, and now we do it backwards, so we add 10 to 30 to get 40, and then we divide 40 by 2 to get 20, which means that x is 20. And there we go. That's equations. Hope you had fun.